All right, question number 19. We want to find the limit of this rational function, and we have a square root. So just like the previous problems, if we were to try to use direct substitution as h goes to 0, we would get 0 on the denominator, and we cannot solve that, so we're going to have to employ some algebraic methods. We can put a 0 on the top and it would work out, but we get 0 over 0, which is an indeterminate form. So this is supposed to be a 4, sorry. So in order to solve this, we want to multiply by the conjugate. So we can kind of get rid of the square root and then get a method or a form that we can solve. So we're going to multiply the top and the bottom by the conjugate of the top. So we're going to multiply by square root 144 plus h and then minus 12. So actually it'll be a plus 12. We're going to change that sign. And we're going to do the same thing on the bottom. Square root 144 plus h plus 12. So when I multiply by this conjugate on the top, it's kind of like using the difference of squares. Square the first, square the second term, and then we'll have a minus in the middle. So limit as h goes to 0. So on the top, if we square this square root term, we'll have a 144 h. We'll just end up losing the square root. And then the difference of squares happens when you multiply 12 and 12. You get a negative, sorry, it should be a plus here. You get a negative 144. So the middle term will cancel out when you do difference of squares. Remember, you just get the result of squaring the first and squaring the second. And so we get 144 plus h and then minus 144. On the bottom, I'm just going to write it as a factored form. So we'll have the h times this expression, which is the square root of 144 plus h underneath the square root, and then we have a minus or plus 12. Okay. So if you simplify the numerator, the positive and negative 144 will cancel out, leaving us with just a positive h. We have a h on the bottom, and then we have square root of 144 plus h and then plus 12. Okay, so we can divide out an h. So again, this kind of like dividing out a factor of 0. So we'll have a 1 over the square root of 144 plus h plus 12. And then at this point, when we use direct substitution, we plug in a 0. We got 144 plus 0. So the square root of 144 is 12. So we'll have, well, I'm actually evaluating the limit, but we'll write it down one more time. We have 1 over square root of 144 plus 12, which that's plugging in the 0 for h. That's going to give us 1 over 12 plus 12, and that gives us 1 over 24. So we get the limit of this function as h goes to 0 is 1 over 24.